Okay, fine. Hi guys. My name is Pavel, and I'm going to show you how modern dependency injection mechanism may look like and how might help us to write nice and pure functional code, having many additional benefits. Before we start, I wish to say thanks to everyone who is attending my speech and say that it's an honor for me to speak here. Unfortunately, I was unable to cross Ukrainian border, and it was a devastating experience, but the committee was so kind to provide me an opportunity to deliver my speech. So thank you, everyone, once again. Um, so, I all know that many people consider dependency injection as a deprecated approach. You may hear or you may think that DI is slow, like test initialization takes longer than execution, etc. That DI is unsafe, like my program compiles but crashes at runtime after a huge delay. That DI doesn't work for modern functional code, like I cannot inject IO into my repository, and DI is full of magic and error. In fact, these are issues specific for web DI implementations, and it's possible to design a better solution which is not suffering from them, and we did it. So, to be very short, here is a stripped down example of a program which uses DIStage as dependency injection. It has an abstract repository, as you can see, it has an abstract repository with two implementations, production and dummy, an application itself, and an entry point, and also some boilerplate intended to wire things together. We may make several interesting observations. At first, as you may notice, all the code here is polymorphic against f, which is supposed to be a moon. There is just one point where f is defined. This is the last line in this of this snippet. When all the business logic it looks like usual code. The glue required to wire things together is non-intrusive and it does not affect the actual code. And also there is a very interesting declaration on line 15 saying roots equals set of something. This is a very important part and we will consider it a little bit later. Does everyone see my screen? Is everything all right? Can you read the text?
Yes.
Okay, great. Let's switch to next slide, and in case someone wishes, we may come back to this one later. So we just had a glimpse of what DIStage can do for us. And actually, it can do a lot more. So at first, it's based on staged approach. It plans all the job first, and only when it executes it, so-called late binding. When it supports garbage collection, so you may define a set of roots entities you want to work with, and all their dependencies, and only them will be instantiated. Nothing apart of dependencies of your roots. When it supports advanced Scala features like higher kinded types, path-dependent types, and so on, so you can use DIStage with your usual code without limiting yourself. You can inject type class instances, etc., etc., etc. And of course, you may use all the good tricks like parametricity and so when DIStage allows you to introspect and rewrite plans before actual instantiation happens. This is especially convenient for debugging because you may dump your plans, you may print dependency trees, you may explore your dependency trees without actual instantiations. But apart of it, it allows you to rewrite plans, and there are several useful patterns we will consider later when it supports cycles and resources. So you may and it is compatible with cuts effect resources. When it allows you to use a pattern we call role-based approach when several applications are cohabiting within a single process, and we will consider this a little bit later. Also, it works in both runtime and compile time. And when it works in runtime, it provides you a support for dynamic plugins, which is a controversial feature, but it may be very convenient in some cases. It has a test kit allowing you to write your tests without wiring boilerplate, and it supports so-called automatic sets, allowing you to get a pre-populated set of all the instances conforming to a predicate. And it has an optional support for circular dependencies and assisted injection, and a lot more, in fact. So, why garbage collection is so important? Let's consider a scenario when we write tests. So in case we have garbage collection, we may define all our test and production dependencies as a flat list, adding some discriminators for conflicting bindings. When we may define garbage collection routes, and only as classes you want, as instances you want to test, and only the actual instances required for your tests will be instantiated. So instantiation of your test context, it will take milliseconds. You may save a lot on test startup time, and also you don't need to mess with your wirings. It's gonna be it will be done automatically by garbage collector, and you may make substantial savings on setup on wiring boilerplate. So here is another example of how it might look like. This example is also stripped down. So here you see a couple of implementations of a repository, production one and dummy one, both bound to the same interface. And when you see a test which is utilizing checking an instance of that interface, and actually the lambda signature on line 11 it defines garbage collection route, and that's it. It works automagically. You don't have to resolve the conflict. You don't need to write any instantiation code, and it will work. Okay. Again, we may come back to this a little bit later, in case someone wishes. So, What else may we do with garbage collection? We may find it an escape hatch of the microservices versus monolith dilemma. So we may develop our services or software components separately, but pack them all together into the same, for example, Docker image, and provide a set of roles we want to start when launching that image, and each role is going to be a garbage collection role. In that case, at one hand, we may have all the benefits of microservices and monoliths at the same time. And for production deployments, we may go microservices way and deploy our product visually, and we may save a lot on different development flows. For example, a developer may get working model in seconds instead of waiting minutes until his Docker Compose environment starts. Also for production deployments, we may get some benefits also. Because we may run several loaded services in one container, thus saving costs on our server bills. So right now I'm going to switch with my copilot, Michael. So please give me just 1 second. Am I on now?
Oh, now okay.
Am I on? Can you hear me? Can you see? Hi. So life cycle. Let's go back. So real applications have to manage a lot of global resources. But connections, we have two connections, web pools, servers, clients, pools. It's a lot of stuff. And a lot of these resources, they also have to be started for your tests. For example, you may want to test against a real database. You probably want to test your SQL queries. If we were to repeat the code required to initialize and close all these resources in main or in every test, that would be a lot of boilerplate, and it would just freeze. We will not be able to evolve our application to do the boilerplate required to add a new component. We need a solution to seamlessly manage global resources and create reusable components, create libraries that will want to work on a shared resource. And in FP, we have a pattern that encapsulates resource management, the bracket pattern, and class resource is a verification of bracket pattern. But the same limitations apply to bracket. When we want to add a new resource, we have to add a new nested scope, and we have to modify old code within that scope or without that scope. We can't compose an application out of completely orthogonal pieces. DIStage addresses that. We can create a new module that allocates some kind of new resource, and we can compose an application out of multiple such modules, just by composing modules together. And all resources created will be allocated promptly and allocated promptly.
Blaze client where there's actually pool. Is an execution context we just bound, and we can use it, and it will be closed correctly after the object graph. After we're done using the object graph, it will be closed correctly. And sometimes we just need to create some mutable state or a concurrency primitive, something that requires an effect to be created, but it doesn't need to be deallocated. In these cases, we can use a form effect binding. For example, here we can create this global sum of 4, zero sum of 4, to limit the maximum parallelism level. Let's say we want to limit the maximum of those possible in the entire coefficient globally using configuration. We create a semaphore parameterized by the value inside the configuration, and after everything that goes through the total class will be left emphasis on the semaphore. That's the end of my section. Thank you. I'll move over back to Paul.
Do you hear me now?
Yes.
Okay. Sorry about this. So let's continue. I have to say sorry. It seems like we are going kind of too fast. So in case you want to explain something, or in case you don't follow, please feel free to ask, because it's a little bit hard for me to speak remotely without seeing my audience. Anyway. So Michael just shown you how resource and lifecycle support works in DIStage, and I have to thank him for his hard work, because this was completely his part. So let's consider several other things which DIStage can do for you. So at first, it has an extension allowing you to inject values directly from your Hocon config, and of course you may implement similar extension elsewhere. So this extension, it enumerates all the missing references in a plan once planning finishes. When it searches all the missing references for a specific annotation, and tries to find corresponding sections in config, in your reference config, or the actual one, and then extends plan with the values loaded from the config. So what does it give us? At first, all the config values are parsed before instantiation even begins, and all the config problems were shown quickly and all at once. And also we provide you a compile time plugin which validates your reference config during compilation. Feature, but still sometimes it may be very convenient. So we support dynamic plugins. So you may just drop all your bindings as classes in your class path, and DIStage may enumerate all your bindings and use them to build your context. It's unsafe, but it may be very convenient while you prototype in your app, because It allows you not to worry about wiring things together at all. And during maintenance, you may switch to static configuration. Also, as I said before, we have optional support for circular dependencies. We use standard approach with proxies. Though with runtime code generation, though binary parameters will work without any kind of runtime coding, and circular dependency support can be completely disabled. And of course, there are standard limitations. So at first, you cannot use injected parameters in constructors. You cannot use them during instance initialization, and you cannot have non-binary circular dependencies involving final classes. When couple of features which may be very convenient for those who use Akka. So we have it's a runtime and compile time code generation. It allows you to bind traits with abstract methods directly, and abstract methods they will be wired using dependencies available in your context. So as I said before, it works as a compile time code. It works as a compile time feature or as a runtime feature. When we have assisted injection, so you may define a trait with an abstract method. Which would work as a factory, and all the values for method signature will be used as parameters to instantiate the product, and the rest and the missing parameters will be taken from context. This is the feature which was implemented specifically for roles with Zakka, and it allows you to easily inject dependencies into your actors. When automatic sets. So as I said previously, you may prepopulate a set with all the instances from your context conforming to a predicate, and here is a simple example of how may you implement a simple lifecycle and resources using this feature. Actually, you shouldn't go this way. You should use our lifecycle support module, but it's just an example. Also, I have to say that set elements, they may be weak reference or strong reference. So weak references, they do not prevent garbage collector from collecting an instance. Let's consider how does it work under the hood. So we have a list of bindings. I turn each binding into an operation of simple Turing incomplete language. When we use dependency information to turn this operation set into directed acyclic graph, breaking circular dependencies if any This directed acyclic graph we may call it project network. It represents all the job which needs to be done to achieve the goal to build our context. When we resolve conflicts in the graph, a conflict is a node with several associated. When we perform garbage collection, when we may optionally when we may apply some other transformations like resolve config references, when we turn the graph back into sequential form, so-called plan, using topological sort. And now the plan may be introspected, printed, or executed in compile time, the code generator, emitting Scala code, or executed in runtime. So here is a simple example of some kind of an application of couple of repositories, couple of services using these repositories, and an entry point. Also, you may notice that there is a circular dependency between users API impl and accounts API impl. So I'm gonna give you some time to look at this example. And now, here are the bindings. So, again, the code, the business logic, and the bindings, the wiring. Also, there is a link. So, and here, how does it look like? This diagram, it was generated by DIStage extension. So there was no manual job at all, and as you can see, it looks very descriptive. It shows you all the dependencies between your entities. It shows that there was an unrequired dependency which was collected by garbage collector. You may notice a circular dependency there, and so you may easily generate such diagrams with just one call. When you may dump the plan as some kind of a pseudocode. Here, how does it look like for our example? Also, you may notice that there is some information allowing you to quickly navigate from your console to your source locations. When you may print dependency trees with one more call, and as you can see, it allows you to easily find all the circular dependencies. And when? So we have a plan. It's a sequence of operations. What may we do with a plan? as I said before, we may interpret it in runtime, or we may generate some code, we may emit some code in compile time. Nice, right? So, this is almost everything. I'm gonna make a short break and let you ask your questions. Do you have any?
Okay, anybody have questions? And can you switch to show your face?
Sorry?
Can you show your face instead of presentation?
Oh, yeah. Hold on. Do you see me now? Okay, hold on. Do you see me?
Yes.
Yes.
Okay.
Hello, Pavel. Thank you very much for this great presentation and for sharing this technology. My question: is there any? Do you hear me?
Could you speak a little bit louder because it's kind of hard to understand what you're talking.
Okay, now it's better.
Okay, fine. Okay, try to speak slower. So.
Okay. Hello. Thank you very much for this great presentation and sharing. Is this better? I'm sorry.
Yeah.
And for sharing this awesome DI framework. My question is there any extensions for Play framework of
Not yet.
Oh.
It's planned, but at this point we have nothing intended specifically for Play. Though it shouldn't be a big deal, it shouldn't be a big deal to support Play. In general, the basic interface we provide, it's kind of similar to Juice, so I think it's possible to implement drop-in replacement for Juice specifically for Play.
Okay, thank you very much.
Yet more questions? Any questions? I have a small question.
Yeah.
Question that you have some constraints such as not using values in constructors. So the question, the policy you enforce the use of such constraints, or if we use the values in constructors, we will see runtime exception.
Okay, so at first, in case you switch off circular dependency support, there will be an early error message. So in case you use compile time verification, your compilation will fail. In case you use runtime verification, your planning stage will for your applications. But in case you have circular dependencies on, and in case you use uninitialized proxy in a constructor, it will be a runtime exception, and there are almost no ways to fix it.
Okay, thanks.
But you may disable circular dependencies.
Okay.
And enforce yourself to write nice code, properly structured, and so on.
Okay.
Any other questions?
Okay. So thanks.
Actually, I wish to show you temporary break, but this is almost everything. Let me share my screen again. Okay. So, DIStage, do you see my screen now?
No.
Yes?
We are seeing you.
Okay. DIStage is ready to use. It was in production for 1 year, more than 1 year actually. All the runtime features are available right now. All the compile time features except of the code generator are available right now as well. So you may verify your plans with a compiler plugin, and there is some limited code generation available. We are gonna rework our roles API in foreseeable future. As well, we are going to support Scala.js, and maybe we may support isolated class loaders, so we may load roles with conflicting dependencies in the same process, and you may follow our work on our GitHub. Also, DIStage is just a part of our stack. We also have a zero-cost structured logging framework, and I highly recommend it. I would highly recommend how to have structured logs without making any efforts. Also, we have several more potentially interesting things, like our own RPC solution, an alternative to Thrift, Portabug, gRPC, and so on, but it's not so interesting at this moment. And in general, if you use Juice, you may try to switch to DIStage. It's easy enough. And DIStage, it was approved by John DeGoes. So those who write functional code may have some motivation to try it too. I mentioned our logging framework, and here is the tease. So, as I said before, you may write typical calls as you usually do, and have structure extracted. And this is everything. Thank you for coming. Thank you for listening.
Thank you.